Today we are going to do a couple of questions based on Euclid's division algorithm. Over here you can see the first question is, use Euclid's algorithm to find the HCF of 4052 and 12576. So what we do is, to begin with, we will first find the HCF of these two numbers using the division method. So over here we have 4052 and we are dividing one two five seven six. Now the first thing, the first time we can divide, we get 3 as the quotient, and we have 12156. Now we subtract and we get the remainder as 420. Now what do we do is that we divide the previous divisor, which is 4052, and we divide it by 420. Now when we divide by 420, we have 9. So 0, 9 2s are 18, 9 4s are 36 and 37. Now we are left with another remainder over here, and that is 272. Now once again we divide the previous divisor 420 by 272. So it goes one time, we are left with 272, and then the remainder is 148. Now once again the previous divisor 272 divided by 148, so it goes one time. Now we are left with 124. Now we are dividing the previous divisor 148 by 124, and we are left with 24 as the, once again dividing the previous divisor 124 by 24, we get 5 times, that's 120, and then we are left with 4, and we divide the previous divisor 24 by 4 and we get 6, so 24. Now we are not left with any remainder. So how do we express this as in the Euclid's division algorithm? So we start with 12576, that can be written as 3 times 4052 plus 420. Now we are in the next step, we were dividing 4052 by 420 and it went 9 times, so 9 into 420 plus 272. Next step, 420 being divided by 272 going only one time, so 1 into 272 plus 148. Once again the previous that is 272. Now we are dividing it by 148 and it goes only one, so 1 into 148 plus 124. Now once again 148 being divided by 124, so it goes only once, so 1 into 124 plus 24. Next step, 124 being divided by 24 going 5 times, so 5 into 24 plus 4. And now finally 24 is equal to 6 times 4 plus 0. Now the last we divided was we divided by 4, so 4 is the HCF. HCF is equal to 4. Now this is what we say is Euclid's division algorithm. So it's always advisable to do it separately and then write it in the division algorithm. Now we will take up the second case, the second question, which is on the right. which show that any positive odd integer is of the form 4q plus 1 or 4q plus 3. Now over here one thing is very clear, that whatever be the number, we are dividing it by 4. Now according to the remainder rule, that when you are dividing by 4, the remainder must be smaller than 4. So over here the probable remainders are 0, 1, 2 and 3. So what we shall do is, we shall write any integer can be expressed in the form of 4q, 4q plus 1, 4q plus 2 and 4q plus 3, because 4q plus 4 remainder cannot be 4, so we need to go only up to 3. Now what do we do is that we pick up the first one. If the integer is 4q, now 4q. Now 4q can be expressed as 2 into 2q, and we know that if a number is a multiple of 2, it's an even number. So this is an even number. We pick up n is equal to, we pick up the next number 4q plus 1, which is 2 times 2q plus 1. Now we know 2 into 2q will be an even number, and adding 1 to it becomes odd, so it's an odd number. The next is n is equal to 4q plus 2. Over here we get 2 common, 2q plus 1. Now whatever be the value of 2q plus 1, because it is being multiplied by 2, it again becomes even. And the last one, n is equal to 4q plus 3, which is 2 into 2q plus 3. Now adding an odd number to an even number always makes it odd, so this is odd. And therefore the statement, any positive odd integer is of the form 4q plus 1 or 4q plus 3. I'm sure you understood both the examples. Thank you for watching.